We now describe the time-dependent reliability function of a component in terms of its random time to failure. So capital T is this random variable, and we can obtain data. We can estimate the density function, distribution function, and other related measures from the data, or if we have one function estimated, we can describe others in terms of that. So let's say there is a test program in which we start with N0 specimens, N0 identical specimens, and then we observe as a function of time how many of them are surviving. So N of T is the number of specimens that are surviving at time T. So the density function of the random variable T can be derived, approximately estimated from the data in terms of its definition. So we observe the number of items surviving at time Ti and at Ti plus 1, so the two adjacent instances, and then use the difference between the two observation times and derive the density function as the ratio that you see on the screen. We can get a similar estimate for the CDF, the distribution function of T, as the ratio of the number of failed elements at time Ti over the original number of elements that we started the test with. Commonly, if we could have delta Ti to be constant, so then some of these computations could be simplified. So with this in mind, let us now go back to the definition of reliability that we had at the beginning of this week, that it is a probability that the item will do its job over the duration 0 to t. We are looking at a component, so the reference to omega is suppressed. We have decided that we are observing failures, so those performance functions, gamma, they are also suppressed, as are the given conditions. So what we are left with is a very simple definition of reliability, that the time to failure will be greater than the instant of time small t in question, which is also nothing but the complement of the cumulative distribution function, the CDF. So going back to the properties of CDF F, we can state that our reliability function is a non-increasing function of time. It starts with 1 at time 0. We are defining the time axis only for positive values, and at infinity, at very large times, the reliability would fall to 0. We can measure it in a test program as the ratio of the items that are surviving at the instant in question. So this way we could get R as a function of time, discrete estimates of R from a test program. And N of T is the number of specimens surviving, and N0 is the original number of specimens that we started with.